Hi, welcome to the TechHub.training solution video for the International Inquiries Challenge in Alteryx. This video will cover one of the potential solutions to the challenge and will follow the solution file that is provided at the bottom of the challenge page. Prior to watching this video, we encourage you to try and find your own solution so that it is more beneficial to your learning process and you become more comfortable with these tools and technologies. However, if you have been running into issues while trying to solve it, or if you have found your own solution already and want to compare it to the one I have, then hopefully this video will be of use to you. After you find a solution, we encourage you to reply on the challenge page with an image of your solution and some insights to how the challenge went for you so that you can be a part of our growing community. So when you open up the workflow that you were given, this is the screen you're presented with. To give a quick overview of the scenario, you work for a firm that does international business in Brazil, and your department is in charge of calculating the sales tax for these transactions based on the states in which your Brazilian clients live. The deadline is coming up for submitting those sales taxes, and the problem that you're presented with is your company uses spatial objects and geographical maps and coordinates to input the sales taxes, and the data that you have does not have which state each city is in, only those coordinates. And so when you consider the map you are using is over a century old and does not include the latest additions to the Brazilian states, then your data is going to be flawed and you doubt that the tax that you've calculated is correct. And so your task is both to update the map that you are given from 1920 and also afterwards to calculate the sales tax. So this image is what old Brazil looks like, and you can see it here with this browse tool, and then this is your ultimate goal for these spatial objects. And you can see that there are several states that have been added up here in the north. Right here, the federal district has moved, Tocantins and Mato Grosso was split. An important aspect of any data analysis and manipulation is understanding first the data that you are working with. And so these inputs have all of that data, or some of it that you need for the solution. So in this text input tool, you have the 1920 state losing area and the new state gaining land. And then in the Brazil 1920 Alteryx database file, you have the nome, which is Portuguese for name, of all of the states, and then the spatial object that exists for it. And then for the same thing with the missing states, you have the name of the new state, which doesn't exist in 1920, and the spatial object that is created for it. So you can use this map to sort of guide you on whether or not you are doing the right things. Okay, so this is the actual workflow that I've created for solving this, and I'll try to go step by step through the tools so that you can understand the flow of logic and of data that I'm using. So first things first is you are told that you should solve and move where the federal district is. This is not a new state. It is being moved from where it formerly was in Rio to in the southeast of Goiás. And so what we're going to do is pull from this 1920 database object, and we're going to filter nome by either federal district, Distrito Federal, or Rio de Janeiro. So if those two are true, we're going to combine the Rio and federal district objects that existed. So let's go back to the original file so that we can see sort of what is changing. If you zoom into Rio, then you'll see this portion that is cut off by a border, that is where the federal district used to be. And so what we want to do is combine this Rio section and this old federal district so that they become one area. And you can see that if you look in the present file. That line is no longer there. And so we're going to do last combination on the names, because the later the better. In this case, since we're moving from old to new, and then spatial object, we're going to combine them. And if we did a browse tool here, so we can see that object, then and run it, then we will see that the old Rio now has that section on the bottom that is part of it. So that's because we're pulling from the 1920 data. We will add the district, the new federal district, later on. And so anything that's false isn't being moved or updated in any way, so we're going to update that with the new Rio, full state without the federal district there, and union them so that they are all the same. Next, we are going to make the adjustments from the old states to the new states as we can, based on the land. And so what we're going to do first is join the missing states database with with this text input tool. And we're going to match them on the new state gaining land from the old one and the missing states. So NOMI from this right database and left from new state gaining land. And what that will do is add the name and the spatial object, or rather it will add the text input names to these old states. And then we will combine that with the union that we just did with the updated Rio. So now we're going to make sure that we only select the relevant fields. We're going to get rid of new state gaining land in this case, and the left name, because it is not relevant to us right now. The left join, there should be no right joins coming out of here, but the left join, or the center join, will have 7 records coming out of it based on the 7 missing states that the 7 states that are losing area, and there will be 17 records that didn't join from any of these new states. So next what you're going to do is use this spatial object tool called spatial process to cut 2 from 1. Essentially, there are these old objects and these new objects that are coming together. And the reason we want to cut 2 from 1 is we want to preserve the borders that exist for the new states and remove them from the old states. And here's a nice visualization that Alteryx gives so that you understand what's going on. So this is the shape that you're ending up with, and it is what the old states will look like. And then you're going to, again, similar to how we did earlier, combine the old state's new land together with itself. So group by the NOMI, and again, that's why we renamed back here NOMI, so we could still do this grouping easily. And then we're going to create an intersection on the spatial objects. And then we're going to join that with all of the states that didn't join from here because they didn't update at all, they didn't lose or gain land, and that will give us our finished Brazil map. So that is probably the most difficult part of the challenge, is getting all of that finished so that the map is updated correctly. Next, you are going to actually put in the sales tax data. And so we have the sales data here. It has the city, the latitude and longitude, and the value of sales. So again, this isn't in the states, and that's why we had to update the map first so that we understood where these locations are. Next, we're going to use the Create Points tool so that these latitude and longitude columns and values have meaning, and our X field, longitude, Y field, latitude. And then we're going to match where these states are in, or these cities, which states they're in. And you will make a centroid field using the records from the U input, and then, so put that in T, our old, the union that we just did with the new map. The input here is the universe, so like that's where we are existing, and then T is the target, so what are all of the different locations that are coming in. So that's called a spatial match. And then the output that is there is going to include a full map and those coordinates. So then we'll join that with the Brazil taxes, which includes just the tax rates for each of the states that exist in the present day. And then we're going to join them so that every value that we have has the tax column there. And then the sales come from the old sales values. Then we will add a formula to calculate the sales tax, which is times 0.01, because these values are in whole numbers. We want an actual sort of percentage to multiply the sales by, and then we will sum that. And this section is just to show the difference in what the sales tax would be if we were using the old map and the new map. And so the fun one to look at is this matching tool. So I'll look at that real quickly so you can see. So this map is produced with all those locations, and the way this join works is matching the states that created here in this match, because we go from having just here's a location and here's its latitude and longitude to it saying, okay, this point is within this boundary, this spatial object that exists on this map. And so that shape that it exists in is the name that is going to be returned. And so it's really cool because if you click on the objects, it will show you the record that it's associated with, and then you can target just the specific locations. So it's a very useful tool for using geographical data that you can be consistent with. And so I copied this whole section and input it into this container up here. And the difference is this is the universe that is being used. We have the 1920 universe here and the updated present day universe here, and the matching is the same. And we can see that there is a $5,000 difference in the sales tax that we reported, and so we saved ourselves probably some headaches by making sure that the tax was appropriated to the correct state in Brazil. So hopefully this video was useful to you. Hopefully you got some good experience with these spatial objects and got some insight into how they can be used in pretty cool and interesting ways to help a business keep track of its data. Hopefully, again, this video was useful in you finding that solution or in your learning.